So we are back with the implementation part here, and it's actually going to be very simple. And I actually forgot to tell you one thing, and that is for actually implementing graph in any language, you need there are two basic approaches for get our work done. The first one is the adjacency list, and the second one is the adjacency matrix. So what I basically mean by that is that you can actually represent graph in a matrix form, or you can represent graph in a list form, which is my favorite part. So I will be using a list in this implementation. I will surely be making a video on how to implement a graph using adjacency matrix. But for now, I will just get the work done with the help of a list. And by list, what I basically mean is that I will be using linked list. So we don't have to worry about the limit of the data. You can add as many vertices as you want. So enough of the talking. Let's get on with our code. So the first thing what we need to do is we need to tell exactly how many vertices are going to be present in our graph. And for that, I will just declare a constructor here that also will be having a name graph, and it will be having the number of vertices. So I will just tell that this is the number of vertices integer v. Now I also need to give it an integer that is going to be a private integer. I actually spelled it wrong. It's private integer, and I'm just going to say integer vertices. That's this. And also I will be having a list. So private list. And in this, I will just tell this that it's just a list and integer type list, and it's actually going to be having an integer data type, right? So integer 32, and the name of this list is going to be ADG. That's simple, right? Now, in the integer vertex in the graph constructor, I will be telling exactly how many vertices I will be adding, which basically means that what I mean by this is that I will be telling that how many number of indexes this list should have, which actually leads me to the point that I actually forgot to mention that it's actually an array of lists, not just list, which basically means is that let me just create one thing for you here. So it's going to be basically like let's say I have one vertex I have a vertex named 1 here. So in 1 is connected to, let's say, 2, and 1 is also connected to 3, and 1 is also connected to 4. So in 1 is the index, right? So 1 will be having a linked list that has 2 here, that's connected to 2. 1 also will be connected to 3, and also will be connected to 4. So this is the linked list, and this is the array. So let's say I had another since we also have 1 connected to 2, 3, 4, we will also have 2 that is connected to only 1 and 3 and 4, and we also have 3 that is connected to 4 and 2. Sorry, it's 4 and 2. So it's not connected to 1, or it's not connected to 3 itself, but this is how our graph is going to be represented. I hope that is clear to you. So once I've done telling you that, now let's just go ahead and then do that actually. So in here we will be actually initializing our list too. So the vertices are going to be initialized. The vertices is going to be now assigned the value of the number of vertices that you just sent to the constructor, that is v. And I will also be needing a for loop integer I equals to 0 and I is lesser than v, and I will increment it plus. Whoopsie, what just happened to me today? So now I also need to initialize the list here. So I will just say adj that I just declared up there, and new integer new list integer, and it's going to be having the type into 32, and here I will just say that it has v vertices, and I will close it. So that's all you need to do. So now you have done that. All you need to do now is you just need to tell that in the integer list we will initializing the. So we have to initialize the list here. So we want to initialize each and every index, right? So I will just say adgi, that's our array, and in new integer do the same thing. New list. I'm sorry, it's actually a list, not integer, and that's it. So that's all we need to do. That's our constructor work done here, right? So let's move on to the function where we add the edge. Now this is going to be pretty simple. You will be surprised how simple this is. I have a function called add edge, and this function is going to be receiving two things here. There are going to be two integers here. I'm sorry, I actually forgot to declare the data type here. So I'll click void add edge, and this will be receiving the already present edge here. So let's say I already had a 2 in my I already had a vertex 2 in my graph. So that's going to be our integer c that is already present here, and that's going to be the new vertex that I want to add and connect to c. So that's going to be v. So if I want to add v, I will just add v and connect it to c. So to do that, all I need to do is I just need to tell that ADG has an index c that I just sent. So this is the vertex that is already present, and in that index, the linked list, add the element v. So dot add v. Simple, really. That's how simple it is. Now we can just move on. So this is basically the way how we create the graph. So there's nothing else you need to do now. So we will be moving on to the public void DFS. That's going to be our DFS traversal, and we obviously need a starting vertex. So I will just call that integer v again, and in this integer v, all I will do is I will just tell exactly how I need to traverse to the graph, right? So in order to traverse to the graph, all I need is a stack, right? So we will be having a stack, we will be having an array. First of all, I'll just tell that we actually have an array which has the name visited. This will actually store the integers that are already visited, or I'm sorry, I'm calling them integers. Actually going to have the number of vertices. It has the number of vertices initialized now. Also, I did the mistake of declaring it as integer as a bool. So this is going to be having the number of elements that are equal to the vertices. That is the number of vertices that we have in our graph, and this is going to be storing the indexes or the true and false on certain indexes, which basically will tell if the certain node is already visited, and if it's marked, then don't visit it. That's simple, right? Now we will come to the part where we want to declare our stack, and the stack will have our integer data type. So int 32, and this has the name stack is equals to new stack, and this is an integer, so that's it. Also just need to declare that, and there we go. Now the first thing we need to do is we need to just tell that the integer v we are sending here, it's obvious that since we are starting from this vertex, it will obviously be visited, right? So all we need to do is that we need to say that visited, and at this index v is already going to be true. So that means that the first vertex is already visited, right? Because that's where we are starting from. And also, since we have visited it, we need to push this into the stack, right? So I will just say stack dot push and push that element. That's v. Simple, right? Now comes the part where we need to move on further, right? So to move on further, all I will say that while stack dot count is not equal to 0, you need to keep visiting it, right? So if something is already visited, you don't have to visit it, and you have to pop one vertex and then move on again. And if something is not visited, you need to just go ahead and visit it and mark it and do all the stuff. So that's the basic part of it. So to do that, I will just say that if I will just s is equals to stack, it's actually going to be v. That's the vertex we just sent here. So v is equals to stack dot pop, and this is going to pop our vertex from the graph, from the stack actually, but for us it's just going to be stars. Theoretically, it's actually a graph, right? So what I'm basically doing, I'm just going to print out s, just like that. So I will say console dot right line, and since our next vertex is going to be something here, so I will just say next, and I will just make an arrow sign here plus S. So it's just going to print the S right up. And since we don't actually have S, we have V in our case. So what we will do is we will just so we actually created as the next vertex, printing our next vertex here. Now what I will do is I have to print out the next vertex, right? So to do that, I will just say that since I have popped that, we have stored V here, right? So the vertex that is popped right from here, that's the linked list that we'll be traversing, right? So I will tell my for each loop that for each integer I, that's going to be our traversing integer in the ADG, and the index is going to be our V, since that's the vertex that we just popped. So we need to visit the linked list of that vertex. So V, and then what we need to do is we just need to go ahead and mark everything visited in that. So I will just tell that if not visited, if the certain vertex is not visited, and in our case it's just going to be I. If it's not visited, then visited. So in this visited, I will just say that visited I is equal going to be true, since we just visited it, and we will also push that into our stack. So in order to push that into our stack, we need to just go ahead and say stack dot push, and in the stack dot push I will just say I. So that's going to be our integer that exists into the V. So that's just going to go ahead and push the things into the stack. Simple as that, right? It's not hard, is it? So once you're done with that, all you need to do now is you just need to print the whole. You just need to go ahead and add edges into the vertex, and then just call the DFS, and it's actually going to print up. So now I will just go ahead and create my graph class construct object here, which actually is going to be G is equals to new. Now I want to tell exactly how many vertices I have created. So let's say I wanted to add 4 vertices here. So that's 4. And now I will say g.add edge, and I will add 1 here. And I also will connect that 1 to another vertex that's going to be our 2. Simple, right? And then I will also add what I just did. G.add edge. I will add a 3 here that also is going to be connected to 1. And I will say G dot add edge. I will just add 1 here again, and I will connect this to a new vertex 4. Simple, right? And now since I need to traverse the graph, I will just say G dot. Whoops! I'm pressing Q instead of G. G dot DFS, and start from 1 and then traverse to the graph. So this is going to print our graph just like that. Let's do this. Print this out and see if this actually works or not, right? So our program is booting up. You gotta wait a bit before it actually loads up. Waiting, and it did print it out 1 here, and then it got an error, and the error is because I actually added add the new vertex in the place of the old vertex, right? So I can't do that. So I need to connect 1 with the new vertex 3, and I need to connect 3 with 4, so that's a new vertex 4. Now I will start at 1. Now I guess that's correct. So you can see it's printing at the 3 out, but we still have the error on line. It's on the line. On what line? Index out of range. Well, we have index out of range exception here, and what this basically means is that whoopsie. The thing is that we actually forgot. The problem is that we actually had the problem with adding the number of vertices. So you can see that I actually have added three here. So 4 basically means that I can add 3 vertices here. So once I'm done with that, I will print my graph, and you can see that the graph actually works. 1, 3, 2. So that's how we actually DFS our graph. Let's say I wanted to add another node. I will just make that 5, and now I can just go ahead and say g dot add edge, and in this I will just connect 3 to the new vertex 4, and now let's run it, and you can see that this is actually working fine, and we have the DFS as 1, 3, 4, 2. So guys, that was it. That was the basic implementation of our graph using linked list, and this is just a basic operation of adding an edge and then displaying all the vertices using a DFS traversal. So I hope you were able to grasp that. Thanks a lot for watching my video. Adios. Bye.